Alright, for video homework 4, I posed the following question. Determine the velocity and position of an electron 0.1 seconds after it was observed resting some small distance in the z-axis above a charged plane of radius 20 centimeters resting in the xy plane. The plane has charge positive 20 microcoulombs and the electron is initially at rest. Assume the particle is very close to the surface and far from the edges. We determine the electric field using approximation, as the particle is both very close to the surface and far away from the edges. So we use the equation Ez is approximately equal to the charge of the plane divided by the area of the plane all over 2 epsilon naught, and we arrive at the electric field in the z direction is equal to 9 times 10 to the 6 newtons per coulomb. Then we multiply the charge, we multiply by the charge of the electron to get the net force, which you can see below, and we arrive at 1.4418 times 10 to the negative 12th newtons. We then use that force to update the velocity of the particle, keeping in mind that it was initially at rest. We also have to divide by the mass of the electron, as you can see, and we get to the bottom where we have the new velocity of 0, 0, and 1.583 times 10 to the 17th meters per second. And finally, we update the position, which you can see at the bottom of the page, and we get that the final position is 1.583 times 10 to the 16th meters in the z direction above the plane.